Welcome to the Master of the NEC podcast, the ultimate destination for anyone passionate about the electrical trade. Whether you're a seasoned electrician, an eager apprentice, or just someone who wants to dive deep into the world of electrical work, you've come to the right place. Join your host, Paul Abernathy, a true authority in the industry with over 38 years of trade experience, as he electrifies your mind with in-depth discussions, expert tips, and valuable insights that will keep you ahead of the curve. Each episode, Paul will illuminate the complexities of the trade, decode the National Electrical Code, and share the latest industry trends, all while empowering you to take your electrical career to the next level. So, gear up, plug in, and get ready to supercharge your knowledge, because with the Master of the NEC podcast, the power is in your hands. Now get ready. Here is your host, Paul Abernathy.
Ho! What up, everybody? Welcome to another episode of Mastering the NEC. My name is Paul Abernathy, your host, as always. Thanks for joining me on this podcast. Today's episode, we're going to be looking at the structure of the 2026 edition of the National Electrical Code. For many of you, this won't be out for a while. It is available in link right now. The publishing of it probably will come over the next couple months, and you'll start getting your copies. You get your first edition. You may have some errors. They'll make changes. But again, the body of it is ready right now on link if you want to get it on your phone and start taking a sneak peek at what it's going to look like. Now, for many of you out there that said, you know what, I'm not going to be on the 2026 edition for quite a while. Why do I need to look at it? And I think the real reason that we start to look at code changes or things in the code is because we want to see where things are going. Because it also helps to clarify where we've been. In other words, if there's an argument over a certain condition, a certain application, there's a high probability that in many cases, those very controversial topics that we've talked about through the years gets clarified as the editions go on and code panels address certain issues. And of course, we all know that the 2026 edition is kind of the start of a new direction or new restructuring, if you will, of the National Electrical Code. We're all gearing up for what we've heard that's going to happen in the 2029 edition. But right here in the 2026, we start seeing some things move to other articles and jump around into different chapters, and things just change a little bit. So we wanted to talk a little bit about that today. And kind of give you a little warm up to it. Obviously, we're going to be doing quite a few videos and stuff on these changes and looking at certain aspects that have changed, so that you can just kind of be aware of it, so it doesn't take you by surprise when states do adopt the 2026. You're already ahead of the curve, and in most cases, it's still going to be applicable to 2023, and in some cases even 2020 that we talk about it, but. I just think it's important that we stay up to date. That's what I'm talking about. So, all right, now let's start out by talking code arrangement, because this seems to be one of the things that can get quite confusing for folks. We're leading up to a major change that's coming in 2029. And so there are some certain adjustments that have to be made in the 2026 to prepare us for that, to prepare all the users for that. And it's going to be different. And it's going to be a new kind of formatting. Things are going to be moved around a little bit. So we're just trying to set the tone for that. But that's what's coming. Now, as always, you've got 90.3. And it basically explains the organization of the NEC. So you go look at 90.3. And it makes it very clear that chapters 1 through 4 apply broadly throughout the NEC. They're general requirements. Okay, so if you're flipping through something and you're in 250, you're in 310 for conductors. You're in the body of chapters 1 through 4. It's probably going to pertain to the vast majority of things that you do on a day in and day out basis. But then, of course, you'll run into specialty stuff in chapters 5, 6, and 7. For example, 680 in pools, spas, hot tubs. They modify or supplement something that may be the general rule in, let's say, Article 250. So it does a little something, does a little something extra. And so this happens also with hazardous locations, 501, 502, 503. You have your general rule, and now you have some modifications that can be made, or some type of change, okay, to the general rule. Now, as long as we understanding how that hierarchy goes, then you're going to be in a good place, okay? So that's the first thing that we want to make sure that we're all aware of. Now, what about this arrangement? What are we talking about in the code? So many of you are familiar with the code. I'm talking 2026 right now, but it is generally the exact same concepts, regardless of the 2020, 2017, 2023. You have 9 different chapters. Chapter 1 being general. So general rules, general requirements. That's typically we're going to see 110. Now, in the 2026 edition, that's where you're going to see calculations, 120, because they apply broadly throughout the NEC. It's the calculations. It's what you do. So that it made sense that it gets moved to chapter 1. And we'll look at some of the different changes as we work through this code change series here. Then you got chapter 2, which is wiring and protection. Chapter 3, which is wiring methods and materials. And again, chapter 3 is going to cover things like your rigid metal, intermediate metal, non-metallic, rigid PVC, non-metallic sheet cable, tray cable. All those type of things are going to be covered in chapter 3 with their own specific articles within that chapter. And then you're going to get to chapter 4, which is equipment for general use. Okay. It's where we also see 422, for example, appliances, things like that, 400, okay, cords, okay. And then, of course, you get into chapter 5, which is special occupancies and locations, okay. So you'll get into certain things like 525. You'll get into all kinds of these, specialty things. Again, 500, 501, 502, 503. Those are hazardous classified locations. So a little bit of special occupancy driven and or special type of locations. And then chapter 6 is specific equipment. And that's where we talk about chapter 6 is pools, 680, things like that. Okay. And then chapter 7 is specific conditions and systems. Chapter 8 is communication systems. Now, it's broken into outside and entering the building. And, of course, chapter 9 is our tables. And we have a lot of various tables that we will look at all the time. Chapter 9, table 8 for conductor properties, table 3 and table 4, table 5, all this kind of different stuff that we'll go to when referenced within the NEC. And so all of those things are how we're dealing it. Now, we also have what's called informative annexes. Now, these informative annexes, which, again, many people want to reference these, it goes all the way down to L. Okay, so you have an informative annex A, B, C, D, E, F, on, all the way down to L. And L in this edition is really important because it is just information, but Informative Annex L lets you see the proposed organization of what the 2029 edition is going to look like. That's big because it gives you that peek into this is what we're going to do. This is what it's going to be talking about, okay? Now, some of the things that we're looking at, all these different annexes, remembering that these annexes are just good information. And a good inspector knows that an informative annex is not a code requirement, okay? It's not. It's good information. Now, it may germane with code. It might mirror code. It might give an example like informative annex D, which gives some example calculations. They're going to walk hand in hand with it, but you don't have anybody enforcing anything based on these informative annexes. They're just there for great information. And I like that. I like informative annexes giving us additional guidance, right? So, for example, recommend tightening and torquing values that come out of UL 486A, 486B. Well, that's in there. It's informative annex I. I like that. So anyway, that's what you got to keep in mind. So that's how our structure is broken down, okay? Now, in 2026, we've got to understand a couple key things that are taking place. Now, you remember when we've always said in this structure where you've got chapters 1 through 4, and I might have just said it, 1 through 4 are the general rule, and then 5, 6, and 7 supplement and modify chapters 1 through 7. That's the way it's been up until the 2026 edition of the NEC. So chapter 8 used to be, it's a standalone enforced. It wasn't germane to the typical chapters 1 through 7. Well, that changes for the 2026. Now 8 moves in. So the language in 90.3 arrangement, again, says chapter 1 through 4 is general requirements. And then it says 5 through 8 may supplement or modify the requirements in chapters 1 through 8. So 8 has been pulled into the fold. So it is very much a part of what was previously 1 through 4, which is general. 5 through 7 may supplement or modify, and 8 was a standalone body. Now it is pulled into the code arrangement. So it's not standalone anymore. It's a part of it. Okay. Now, while chapter 8 still appears in the 2026, it's not exempt anymore from 1 through 7. It is subject to all those modifications. So that's the first thing you want to try to keep in mind, because again, a lot of people in their transition are going to think that it's independent. I don't have to meet certain requirements unless it's referenced, okay, from chapter 8. That's not the case anymore, okay? Keeping that in mind. Now, the code is broken down into various articles. Y'all are aware of that. You have different articles, Article 250. You have Article 334 for non-metallic sheath cable. You have all these different articles. And then within those articles, you have what's called parts. You have part 1, part 2, part 3, part 4. And a lot of the wiring cable, for example, is just 3 parts. But you take pools, spas, and hot tubs, for example, 680, you got 7 parts. I mean, you got a lot of parts. Speaking of which, shameless plug, we got Vince Delacroix coming in the studio in a couple of weeks. We're going to be doing the pool, spas, and hot tubs. We'll be looking at Article 680 for the 2026 code. So I'm excited about that, because we're going to dig into a lot of changes that took place. And we'll probably have some podcasts with Vince as well, talking about what he does and all the stuff that he does for the industry, because he does amazing stuff for the industry. So we're going to be talking about that as well. So make sure you catch some of those episodes. They'll be on the same platform as this is, so you won't miss it. But we look forward to Vince coming into the studio. So you've got we got the parts, and then of those parts, you have what's called sections. Each section would be like .3, .5, .8, .10, whatever it is. Those are the various sections. So you have articles, you have parts, you have sections, right? And then you got, a bunch of different things, like you got informational notes. Again, informational notes, which years and years and years ago now, we're moving on, were called fine print notes, but they're not that anymore, right? We've changed. We've made a progression as well, right? And then, of course, you'll have exceptions, and exceptions be exceptions to the general rule. So you've got various basic rule, and that's going to be stated in standard type. And then, of course, you'll have exceptions, which typically are in italics in the code, so that you can see what the exception may be. But that's pretty much the norm. That's been the way it's been. And then we have footnotes that are going to be in the code. Okay, so keep that in mind. Now, general requirements, we're going to be looking, and some of the changes that we're going to be having, or what we're going to be seeing when we come through the NEC, is there is going to be quite a few changes that took place in Chapter 1 that are significant. The calculations obviously went from 220 to 120. Okay, energy management systems, that's moved to 130. So some significant changes, but again, that's general, because those calculations are general. They apply broadly. So it makes sense that it should be in the general rather than in Chapter 2. It makes sense. It aligns a little bit better. And So remembering that 110 is general requirements for electrical installations that, throughout the NEC. It's general applications to the various articles. Unless, of course, they're modified in some form or fashion by some other article. Okay. In 120, it's going to provide from 220 to 120, it's going to provide the general basis for our calculations. And that's going to be for calculating branch circuit, feeder, and service loads. It's just a realignment. That's really all. And it makes more sense. Energy management system is going to be in 130, that type of thing. Okay. Just some changes for that. And Article 300 is going to be an introductory article for Chapter 3. And it's going to provide general requirements for wiring methods and materials. Okay. But again, it can be modified. It can be changed based on the other articles that are within Chapter 3, specific to certain types of wiring methods that are going to say, look, for this type of wiring method, you can do a little something different than the general rule. Okay, so it's important to make sure that we understand how the structure is going to flow and when something can modify and when something can supplement something. Makes sense? Okay. Just want to make sure we're all on board as we start to dig deeper into some of the significant changes that are taking place in the 2026 edition of the National Electrical Code. Not just the fact that it's preparing us for a new direction, right? Little new direction of how it's going to go. Now, one of the questions that come up quite often and becomes really a big debate is terminology. So Article 100 is going to obviously cover, and we made that shift in the 2023 where all of the definitions got moved for the most part over into Article 100. Gives us one clean place to go look for the various definitions, and definitions are extremely important, especially if maneuvering through the NEC. But one of the things that people ask from time to time is what if a specific definition or specific term is not covered in the National Electrical Code? Where do I go to get a definition for that? Maybe a generic, typical, general used definition, right? Well, we know that Article 100 contains those, the definitions that are basically extremely important for the applications and use of the NEC. We knew that. We teach people that these are. It's really Article 100. The definitions are not designed to give us very generic terms. These are very technical terms and definitions, right? And so we have to understand that there's going to be a place where we have to be able to get some of the very generic terminology in order to be able to use that document sometimes. So while it's not really stated in Article 100, you use the Merriam-Webster's Collegiate Dictionary is referenced, okay? And, of course, the building codes and things like that. None of this is stated in the NEC, but that is the general, and that is the method that is promoted by an FPA, and the concept is to use for definitions that are not specifically germane to the NEC. They would be using the Merriam-Webster's latest edition, the Collegiate Dictionary, and that's what would be used. Okay, so if you're looking at a term, you're like, this is some obscure term. It's not. It's general, but it's obviously not going to be covered by the NEC. Where would you go? That's where you'd go. Okay, just so everybody's clear. Now, some of you are going to get into this and start getting your electronic versions of the NEC. You're going to start looking at it, and I encourage it. Start looking at the changes, getting familiar with them, seeing maybe things that you've argued in the past, and you're saying, dude, I want to go see if something's changed. If something in what I've been arguing for years has finally changed, and does the new NEC address that? Well, if you're flipping through the NEC, you'll see some N's, okay, the letter N in the left margin. And if it's just an N, you know that it's new, okay, in the left margin. If you see an N that is shaded, then it's treated as new rule, but it's been relocated. In other words, it's new to this area. Makes sense? So when you're looking at the code, I mean, I guess the key thing for me is focus in on the N for new and read it fresh, right? Kind of read it fresh and kind of got to get a kind of a feel that it's fresh and it's kind of a fresh look, that type of approach. And that's kind of how I would address you seeing the N in the left margins. Now up front, let's go on and let's knock out the new articles that have been added to the 2026. Okay, so you're clear on what's new. We have a new 206, which is remote control and signaling circuits. Originally it was 300.26. Now it's 206. Okay, that's a move. We have branch circuits over 1,000 volts, and that is 265. Okay, now that's going to confuse a lot of people because that used to be part 3 for feeders. Okay, for feeders that are over 1,000 volts. Okay, no, excuse me, branch circuits that are over 1,000 volts. That used to be in 235, which was part 2, is now 265. And of course, feeders that are over 1,000 volts is now 266. Okay, so that can be confusing for folks because that used to be in the 235. Okay, now 235 has been deleted now, obviously, because it's been broken into their own articles. Okay, so that'll be a shift for people to see that. But again, this is kind of aligning with the new structure, which again you can go look at in your 2026. If you have the electronic version, you can go to Informative Annex L, I believe I said, and look and see what it's going to look like. But I'm sure they'll still be evolving because that's a cycle away now. We just now in the 2026 are ready to release it. So again, there's going to be work that gets done to that. So, and then of course you have, again, that was 266 for feeders over 1,000 volts. Then you have 267, which is outside branch and feeders over 1,000. Again, this used to be part 4 of 235, which again is that, and it also deletes 395. Okay, for those that remember 395, that was overhead, outdoor overhead conductors over this. So now it kind of aligns itself a little bit in how that's going to be done. Okay. Next we'll be looking at is services over 1,000 volts. That was part 5 of Article 235. Well, obviously 235 is gone now. So just keeping in that pattern, it is now 268, right? And with that, and I'm in code panel 5, and we were all for expanding out grounding and bonding specifics. A lot of it was a cut and paste from regular 250, but there are some nuances to over 1,000 volts that we wanted to capture. And so it used to be in part 10 of Article 250, but now grounding and bonding for over 1,000 volts, okay? Not your everyday application, your 480, 277, 240, 120, your normal day in, day out building wire stuff typically, okay? That's 250. But we do have a 270 now that's going to be for grounding and bonding over 1,000 volts, okay? Next is 264 electric self-propelled vehicles to kind of separate it away from 625, which is more about the EV charging aspect of it, the equipment, and more addressing the electric self-propelled vehicles in 624. So a kind of a splitting up of 625, if you will, and trying to create a 624 that's more dedicated to the vehicle aspect of it versus the charger or charging aspect of it. Kind of what took place with that. We have a 720 that's getting added, and that is general requirements for limited energy systems, wiring methods, and materials. Okay, so 720, again, limited energy systems. We have 721, which is power sources for limited energy systems. We have 722, limited energy cable requirements. Okay. So again, all about limited energies, the class 2s, class 3s, all these type of things. We have also, if you remember last cycle, we had the introduction of the class 4 fault managed systems. If you've never watched any of those videos over on YouTube for Volt Server, and you want to learn what's the technology that's down the road that's coming, it's interesting. Go take a moment, obviously after my podcast. Don't do it now. Don't leave now. And go look at those videos. It's a very interesting technology. So that's your homework. Your homework is to go look at some of those Volt Server videos over on YouTube. Interesting technology, I will say. We have a 723 that's being introduced. That's raceway, cable routing assemblies, and cable trays for limited energy systems. Okay, so not only you're going to deal with the sources of this limited energy, the cable requirements of this listed energy, the general requirements for limited energy, but now you're going to have requirements that are specific to raceway, cable routing assemblies, cable trays, yada, 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 for limited energy systems. Okay. 742, over voltage protection for limited energy. And of course, 750, which used to be energy management, that got moved to 130 to make way for 750 for grounding and bonding for limited energy. Okay, so you see the pattern here, limited energy expansion, those type of things. Now, with that said, some things had to be relocated. And again, a couple things that we relocate was obviously 770, which is optical fiber cables. Well, that's a no-brainer because that gets relocated over into 722, okay? Because that is a limited energy cable, and there's limited energy cable requirements. So it makes sense. So 770 gets absorbed into the new 722, okay? And it's going to be part 7, by the way, in that, all right? That also makes the way for the communication circuits in 805 to get, relocated to 722, 742, and 750, okay? Because your grounding and bonding requirements, your over voltage protection for this limited energy, and of course, obviously we're talking communication circuits, so we're also going to be talking about limited energy cable requirements. And of course, as always, you got 720, which is basically the general requirements for these limited energy systems, okay? So you see how it's kind of rolling, if you will. And of course, 840, which is premise-powered broadband communication systems, also gets deleted in this edition of the NEC and gets absorbed into the other specific articles, that type of thing. So, makes sense? So it's kind of the alignment. So that's the new stuff that's coming in the new articles. And I fully get it. You may pause this podcast. You may rewind it back and listen to some of these again and see what's coming. But that's what you got. That's your new articles and what's being deleted. Okay. Now, some of the things I want to tell you about the listing requirements. So for 2026, there's been a significant change in the structure of .2, which is your listing requirements, and more germane really to various wiring methods that do have a listing requirement. Wiring methods typically are, all of them are, rigid, intermediate, AC, MC cable. All those are listed products. And under .2, before when it was required to be listed, now they're going to be listed and identified, but then it kind of goes one step forward. And I'll use AC cable as an example. So 320.2, for example, it's just convenient to use it. It says the following shall be listed and identified. So you've got AC cable. That's not a big change, okay? Because it was already required to be listed and identified. It's AC cable. Next is probably where we're going to see the biggest change is cable ties, staples, straps, and hangers have to be listed and identified. Obviously listed and identified for use with AC cable. Not just any strap that you can find anymore. Okay, this is the thing to remember moving forward in 2026 is that staples, okay, now cable ties were required to be listed prior in many of these cable sections or these cable articles. They were required to be listed and for that specific use, okay, securing and supporting. But now you're seeing the straps, the hangers, the staples, and when it says listed and identified means that it is listed and identified for use with obviously the wiring method in question, which is AC cable. So this makes it very clear that you don't use an EMT strap to secure AC cable just because it works, okay? Also, AC cable fittings used for connecting boxes, cables to boxes, cabinets, or other equipment all have to be listed and identified. Okay, so that is where we're going to see dot 2 going. It's more specific now in the way that it wants to address it. So keeping that in mind. And again, by the way, this is throughout. That wasn't just 320. It's the same thing when you go to 330.2, 334.2. It's the same concept. And, the argument was, do you list a staple? Well, there is a standard for that. And so because there is a standard for that, it just was maybe not followed that much. But now the manufacturers will, and they will, and you will see supports and straps and hangers and cable ties and all this other type of stuff getting evaluated through a third party now so that you can use it with the product. Okay, so that's where you're going to see some of the changes that take place in that. Okay. Now, in many cases, you're going to also now run into a dot 3, which is the reconditioned equipment. Okay, and I'm using an example here. 312.3 is reconditioned equipment. Of course, we know 312 is dealing with cabinets, cutout boxes, meter socket enclosures. So I'm just using that as an example. And when you go look at that, you'll see an N in the margin, in the left margin. So it's reconditioned equipment. So if you look at it, you're going to see that what can be reconditioned and what can't be. For example, boxes, cabinets, cutout boxes, you'll see that there's a 312.3A and a B. And you'll notice that A says permitted to be installed and B says not permitted to be installed. Okay. Now, A is very vague because it says reserved online when I'm looking at the 2026 edition in Link. Okay. But more telling is you look at what the not permitted to be installed. It says the installation of the following reconditioned equipment shall not be permitted: cabinets, cabinet cutout boxes, cabinet meter socket enclosures. So you cannot use reconditioned cabinets, cutout boxes. And this is big because there's a lot of people out there that use the reconditioned equipment, or they have some cabinets sitting around or whatnot like that. And it makes it very clear that you're not going to be reconditioning them. You're not going to be reusing them. Okay. So the more and more that this comes in a line, it's going to tell you certain things that you just can't recondition. Now, we already were there on what could be reconditioned and wasn't, but this is just going on a little bit more of a new provisions, but to specifically address certain things. Okay, so I'm not totally opposed to this concept. It's being very specific what is permitted and what is not permitted to be reconditioned. And again, it makes sense for us to, if we're going to go down that avenue of what you can and can't reuse, which, by the way, a lot of this started. A lot of this thoughts about reconditioned equipment and what could be used was after Katrina, when we had all of that in New Orleans, all that flooding, and then equipment started migrating its way as being replaced. And then people would say, well, let's just dry it out and reuse it. And it found its way up north into Texas and other places. And that became a problem because the equipment would fail and there was no checks and balances on it and things like that. So it was really important to ask the manufacturers to step up and say, okay, of your products, I mean, these are your products. You know them better than anybody. what really can be reconditioned and what really can't be. Like a GFCI, AFCI, for example, device, that is not something that is reconditionable. Okay? So you're like, nah, it's not something you're just not going to recondition. You're just going to replace it. And so that one, even though that one's a bad example because that should be common sense because of electronics and whatnot, we still needed a little more guidance on that. So I'm all for this structure change because as an electrician, I just tell me what I can reuse and what I can't. That's all I want to know. That's it. So get the manufacturers involved so I can look at something and say, oh, well, crap, good. I can't reuse it. Fine. Let me just buy a new one. That makes sense to me. Okay. But I think the biggest one, I think that the biggest of what we're going to run into is in 314.3 when you're looking at the not permitted to be installed. 314.3a says permitted to be installed and says reserved. Okay. But if you look at the not permitted to be installed, basically, and this is going to be a shocker for many of you out there, the manufacturers have stated, whether you like it or not, whether you agree with it, whether you say it's just because they want you to buy new equipment. You know what? Let's just ignore that. And it says that not permitted to reuse or recondition outlet boxes, device boxes, pull boxes, junction boxes, conduit bodies, fittings, and handhold enclosures. None of that can be reconditioned. So really, it's going to say that anything that puts one of those boxes, even in their associated fittings, under exposure, whether it's flooding, whether it's whatever it is, whatever condition of use may cause something to have to be reconditioned or cleaned up or whatever, then you can't reuse it. This was huge. I mean, this would be huge in Texas because I don't tell you how many times I'd go in the city and you'd have inspections and you go out in the county and people are reusing old crap that wouldn't pass in the city. Well, now it's cross board. You're not going to use any of these things. So no need to save your outlet boxes, no need to save your device. Although at the end of the day, I don't know who would ever know, you know what I'm saying, if you're just using old nail ups or whatnot. I'm just saying, but it's very, very generic in how it states it. It makes it very clear. Reconditioned equipment installed in the following, the installation of the following reconditioned equipment shall not be permitted. Outlet boxes, device boxes, pull boxes, junction boxes, conduit bodies, fittings, and handhold covers. All of that. Now, obviously the savvy code person is going to say, well, Paul, I guess when you read that, you got to go look at the definition of reconditioned equipment. And okay, so we'll go look at that. And it says, what is reconditioned equipment? It's electromechanical systems, equipment, apparatus, or components that are restored to operating condition. This process differs from normal servicing of equipment that remain within a facility or replaced on a replacement of listed equipment on a one-to-one basis. So for me, it's about trying to take equipment, clean it up, put it back in service. That to me is a reconditioning issue, right? It's not, for me, a box that's a listed box. And again, not all boxes are required to be listed. Okay, keep that in mind. But you have a piece of equipment and in some way try to recondition it due to some exposure or something that's been exposed to, that's a no-no, okay? But I would argue, and again, I'm always controversial, a nail-up box is a nail-up box, and there's really nothing to recondition about it. If you got one and you reuse it, I don't have a problem with it. But my problem with this is you're going to have possibly, maybe, potential of AHJs trying to bring this up, especially if they see a junction box, for example, that has plugs in it where it was used somewhere else, and it's being used in another location. That could, be an issue for that jurisdiction, for that inspector. He could raise that issue. and say, well, that's reconditioned. Well, no, maybe repurposed doesn't necessarily mean it's reconditioned. So I think we're going to have some, there's some flexibility. Now, obviously, the intent here was for critical devices like, GFCIs, AFCIs, fuses, things like that. Obviously, we don't want to recondition those, rebuild them from one state to another state and re-implement them when they are clearly, it says in the code that they cannot be reconditioned. So I don't want to blur the line there. But when you have 314.3 stating things like you can't recondition junction boxes, we have to understand, well, okay, what is the line? What if I'm using it in one job and I take it out and I put it in my truck and I reuse it on another job? That's not necessarily reconditioning it. It's repurposing it. So again, the reason I throw this out there is because I don't want it to become a problematic issue for enforcement and contractors. Okay, that type of thing. You get what I'm saying? It'd be very different, for example, if the box is being used in a location where it's submerged in a flood or something like that, then you're cleaning it and all that in order to reuse it. That's reconditioning, and that you're not supposed to do. Okay, that you can't do. So I don't want to get people confused if I just take some nail-up boxes in a house and I'm storing them in my truck because I did a remodel and I want to reuse the nail-up box and the box is perfectly fine. I'm not really reconditioning it. I'm repurposing it. It didn't lose any listing, or if it was listed at all. You get what I'm saying? So I don't want there to be a confusion with that one. And hell, I might not have done a very good job. I might have confused you anyway. So that wasn't my goal. That wasn't what I was supposed to do. But hell, I'm not perfect. So, all right. Now, there are some terms that are throughout the NEC that have been debated and confusing, and for clarity and things like that through the years that we're going to try to clarify. And one of those was branch circuit overcurrent protected devices. That's confusing because it's used on feeders, it's used on branch circuits, right? It's used on service conductors, it's used on other equipment. And so the term to use branch circuit overcurrent protected devices, the way the code uses it, was very confusing. So how about this? How about we just say, look, why don't we just call them overcurrent protected devices, OCPD, the acronym, and just remove the reference to branch circuits, feeders, service conductors, equipment. Just remove all that. Okay? Why not just do all that? And so that's what took place in the 2026 edition of the NEC, and broadly. Okay? And so we also had to figure there needs to be a way to make this very clear for the end user. And this is what I like about the way that the code is trying to go. And again, I was strongly against, at the beginning, the 2029 change perspective of how it was going to go, the proposed, whatever. And then I got more in looking at it and then saw what we're going to do in 2026, but looking like we're setting the stage. And it seems to me, in my opinion, that we're making an effort to make the NEC maybe a little more easier to understand. You know what I'm saying? Just a little more easier to understand. The reason I say this is because now when you take the branch circuit overcurrent protected device and you say, okay, we're going to break that down now so that we can be clear that these things, these overcurrent devices, apply to branch, feeder, service. They don't need to be called branch circuit of it. That's confusing. But when I do that, I need to tell you, okay, well, what are overcurrent protected devices? Now, we got 240.6, which gives you the standard ratings of these overcurrent protected devices, but we needed to add something else that said, okay, what are the overcurrent protected devices? So 240.7 was born, and that is new. And it basically says, unless permitted elsewhere in the code, and that usually is language for unless it changes it somewhere else in the code, this is a general rule. This is what you're going to follow. It says overcurrent protected devices, or OCPDs, for protecting branch circuit feeders and surface conductors and equipment shall be one of the following. And now it gives you a list item. Makes more sense. You want to know what an overcurrent protected device is? Okay, it's number one, it's a molded case circuit breaker. Standard breaker you see in your panel every day of the week. You have low voltage power circuit breakers, typically have a little bit higher ampacities on them, but again, they're just low voltage. Okay, 1,000 volts less type of applications, low voltage power circuit breakers. They're considered overcurrent protected devices. Great. Solid state and solid state hybrid circuit breakers. Okay, they're overcurrent protected devices. Okay, fuses, Class C, CA, CB, CC, CF, G, N, J, H, K, L, R, T. I think I said N. There's no N there. But anyway, you get me. It's Class H, Class J. They're all overcurrent protected devices. And we knew they were, but it's now with a little less confusion because they're just overcurrent. To get away the argument when we had to tell somebody that the breaker that was protecting a feeder was a branch circuit overcurrent protected device, and everybody would go, well, shit, I thought that was a feeder. And it's maybe and it may not be. If it's just going to something like a range, then it's still just a branch circuit. But everybody sees that 2-pole breaker and thinks, oh, that's a feeder. No, it's still a branch circuit. However, you still have a breaker that could feed a remote distribution panel, and it still would have been called a branch circuit overcurrent protected device. But no, it's a feeder, and it's protecting the conductors downstream to another panel. So it's an overcurrent protected device. It's not necessarily a branch circuit overcurrent, but that's the way it was called. It avoids a lot of confusion. Really does. It's a great change, by the way. I think I'm all for clarity. I think it's a better clarity change. Also, to round it out, you have Edison base, the screw-in Edison base, Type C and Type S fuses. Okay, older style Edison base fuse screw-ins. And then, of course, it says other fuses or circuit breakers labeled as suitable for the application. That's a generic one that's going to catch a lot of things. But again, they're going to be very clear moving forward. If they're a circuit breaker and they're for a specific application, they're going to be still, that's their function. Then they're going to be an overcurrent protected device if they're being used in that application. Okay, so that's a number 6 is more of a catch-all, if you will. Okay, so I like it. It's one of those things that, again, makes it very clear. Now, something you will notice that's missing from this list, okay, is something called supplemental overcurrent protected devices, which, again, is not going to be an overcurrent protected device. That's important because we talk about bathrooms and you have supplemental overcurrent protection, which aren't under the same rules as you would have for the overcurrent protected device requirements. And so it makes it so much clearer now, in my mind anyway, maybe not on everybody else's mind, but in my mind, it makes it a little cleaner. It's a good separation because supplemental overcurrent protection devices have their own definition. They have their own rules in Article 100. They are defined. Whereas now, overcurrent protected device is very clear what is and what is not considered an overcurrent protected device. I think it makes it clear to me, a little more clearer, if you will, moving forward. As you heard me at the very beginning of this podcast, you saw where I talked a lot about the expansion of limited energy and the introduction of new articles and some realignments. Talking about things like 720, 721, 722, which was there. It's just been revised. But you have 723 that is new. 724, which is there in the 2023 edition. Again, that's Class 1 power. That's more like our normal power. But then you get into Class 2 and Class 3, which has been revised, and it's 725. And then, of course, we had introduced in the 2023, we had a more clearer definition of what's called Class 4 fault-managed power systems, which got introduced in Article 726, I believe. But now you're seeing new Articles 742, which is, again, the overvoltage, kind of like we have overcurrent, and we have overvoltage for these limited energy systems. And then, of course, the 750, we talked grounding and bonding. And, of course, you still have 760, which, again, is still limited energy for the most part. but it is revised. It has been revised and clarified. 800 as well has been revised. 805 and 840 have all been deleted. Right? And then 810, 820, 830, all those for premise-powered communication systems, network-powered broadband, community antenna television and radio distribution. All of those have been fairly revised in order to kind of harmonize in this thing with limited energy articles. And, I did hear recently that a lot of the data center folks are starting to meet now and trying to find a way to lower their power usage by using DC, which again, Thomas Edison would be like, yep, see, I told you, and Tesla would be like, nah, get over it. But at the end of the day, a surgence of a lot of systems that can integrate that are using less energy, lower energy. And you've heard me talk about Volt Server. They're not the only ones. They were the creators of this Pulse system. It's an amazing technology. It's Pulse DC, right at about maximum 450 volts, and its hertz is between 500 to 700 hertz, and it fluctuates. It pulses. It can have an AC or DC supply transmitter, and then all of a sudden it goes through a class 4 fault managed limited power cable, and it gets to a receiver, and the receiver supplies various electric loads, whether it's taking it purely DC to DC, or if it's a AC to DC conversion, or if it's a DC to AC inversion, whatever it is. And I probably got that backwards. I can't remember. But anyway, whatever it's doing is getting more and more into what people want. Now, again, it's kind of ironic that the class 4 fault managed systems are considered so safe, and they promote them as so safe, and it's pulsed. It's even safer than AFCI and GFCIs and all this kind of stuff. And obviously, it's not going to handle massive loads. Okay, you have limiting factors here on the transmitters and receivers and the conductor sizes, but at the end of the day, we're not talking about running 1,000 amps through these things. So it's very limited in that scope. But again, the fact that it can do voltages up to 450 volts and send them long distances in these packets makes it very promising. And there's places around the country right now that are utilizing this type of system to do lighting and things like that. And not so much very load-dependent applications yet, but for the most part, they can handle lighting very well. Most applications, monitors, computers, terminal, all that stuff that we'd have to convert to DC anyway, like with LED lighting. I mean, why have to go from AC to DC, or whatever? Why convert? And if you can send it longer distances, pump up the voltage and go DC and be able to, it just makes sense for a lot of our lighting needs now that the lighting is getting to 13 watts and all these kind of things with LEDs that are going to equivalent to 60 watts and all these kind of, it makes sense, right? Power consumption, everybody's worried about energy and yada. So it makes sense. So these things are going to be coming on. I employ electricians out there. Get familiar and maybe try to find your niche. Now, the irony I was talking about is that these aren't permitted in that I'm aware of. I really haven't looked that deep into the 2026, but in 2023, you weren't permitted to use a class 4 fault managed system in a dwelling. That's weird to me because I would think you could get away with big dwellings and do all the lighting in this type of stuff and all the heavy loads and demands on devices that use DC that are going to have those power bricks that convert it. I would think that this would be safe and somebody would be pioneering this, but in the code, it was not permitted in dwellings. So it was very heavily commercially was driving it. And so I imagine that will change. Okay. Whether it has already, be honest with you, I haven't looked. I really haven't looked. I probably should look, but I haven't. Once that changes, you're going to have houses that could be 10,000 square foot, but have 100 amp services. I mean, you could, if it had gas appliances. Well, I mean, I'm just saying in theory, if the majority of the loading was being handled from a DC direct, then, you're just offsetting the AC loads to the different things. So, I mean, if you think about it, it is plausible. It really is. But I don't think we're there yet. And The beauty of the way that the 2026 code is addressing limited energy is to try to separate these things out so it is less confusion, because it gives you, obviously it's giving us more articles, and the more articles are going to be more specific to what we're trying to address. So that's the effort that it's trying to do, okay? You kind of follow the logic train here on that. So, okay, that's it for that. All right, folks, hopefully you got something out of today's introduction. We're just kind of dipping our toe in the 2026 edition. We will have other episodes that talk about it and get a little more detail into it. But I'm hopefully just kind of give you a little bit of a sprinkling, if you will, of what's coming in the 2026, the thought process of where it's going. If you get your hands on a 2026 edition, obviously it's available in link, and you can look at it and kind of see the structure and get familiar with it. And some things, it's just going to add clarity, a little easier to understand some things, and it's going to, maybe it doesn't change what was in the 2026, for example, for some specific article or section, but sometimes when a rule changes to add clarity, it wasn't intended to change the rule. It was intended to make the rules read better and a little easier to understand and make it more pliable. And so there's not a conflict between an interpretation that an inspector may give and the installer. That might be the only reason something was changed. Of course, could be just a brand new change. But I think you see this is why we did the code panels and why the process at NFPA does this every 3 years, because there is not to force you to have to learn the code again. That's, some people think that's what it is, but that's not it. And it's not an effort to keep you confused. It really is supposed to be an effort to catch things that were missed, add things that were that needed to be clarified, add new technology as it emerges, and enroll it into the code and create a minimum safety standard that everybody can understand a little bit better. That's the goal every 3 years. Now, whether we achieve that or not, I can't, you got to be the judge of that, whether you think we actually achieve it or not, but there it is. All right, folks, we will catch you on another episode of Mastering the NEC. My name is Paul Abernathy. Thanks for joining me. Hey, if you're looking to learn the National Electrical Code just a little bit better and you want to get into our Fast Tracks family, do me a favor. Go over to fasttracksystem.com. Watch our video. It's under the info tab in the navigation. Watch the video about our courses. Read the blogs. Enjoy those. Join our message board. We have a discussion forum. Look for that. And just chime in. We'd love to hear from you. So just broaden yourself and learn as much as you can. That's what we're here to do. Till next time, folks, stay safe. God bless.
Thanks for tuning into another electrifying episode of the Master the NEC podcast. We hope you're feeling more powered up and ready to tackle the electrical world with the knowledge and confidence you need to succeed. Remember, in the electrical trade, knowledge is power, and we're here to make sure you stay plugged into the latest insights, tips, and code updates. If you enjoyed today's episode, don't forget to subscribe, leave us a review, and share the podcast with your fellow electricians and industry pros. Until next time, keep your tools sharp, your circuits clear, and your mind focused, because here at the Master the NEC podcast, we're all about sparking your success. Stay safe, stay smart, and keep mastering the trade. From all of us here at Electrical Code Academy, thank you for all your support, and we will see you on the next amazing Master the NEC podcast episode.